Good morning, students. Today we are going to discuss about the microwave tube. Microwave tubes are used to overcome the drawbacks of conventional tubes. In this microwave tube, electron transient time is used for microwave amplification. Microwave tubes are structured used for either generation or of microwave frequency signal or to amplify the microwave frequency signal. The range of frequency of microwave signals are 2 GHz to 300 GHz, and for radio frequency it is above 2 GHz. To generate a RF signal, we use RF oscillators, for example, LC oscillator, crystal oscillator. Okay. There are two types of microwave tubes. O and M. O type, that is original tube, and M is magnetron. Original tube are also called as linear beam. In this, electron beam acquires straight path. That's why it is called linear beam. In these tubes, velocity as well as density modulation takes place, and it creates a bunching effect in this. In this, electron bundles are created for a period in which microwave region, in the microwave region. The examples of O tube is klystron and traveling wave tube. Klystron is further divided into klystron amplifier, reflex klystron. So, an M-type magnetron, it is a such tube in which electron beam is traveled in curved path. Whereas in O-type microwave tube, we already discussed, linear beam is followed. Whereas in M-type, curved path is followed by the electron beam. These are M-type microwave tubes are cross-field devices where static field is perpendicular to the electric field. And the example of M-type microwave tube is magnetron. Let's discuss about the klystron. Klystron is a widely used microwave amplifier, and it operates on the principle of velocity and current modulation, and it is of two types. Two cavity klystron or multi-cavity klystron and reflex klystron. Two cavity klystron is used as low power microwave amplifier, whereas reflex klystron is used as low power microwave oscillator. Okay. So today we are going to discuss about the reflex klystron, which is a very important question. So reflex klystron is a in two cavity and multi-cavity klystron. As we know that these are power amplifiers, so they are not oscillators. So in order to get oscillation, a feedback needs to be applied to the klystron amplifier. In a feedback oscillation, a part of signal is applied back to the input, and the phase of the feedback signal is same as the phase of the input signal. To provide feedback, For the crystal, a second coupling loop may be provided to the catcher cavity. Okay, as you see in the figure, first we discuss about the construction of the reflex crystal. As you see the figure, it consists of a catcher and anode cavity. Focusing electrodes are here. These are focusing electrodes. This is a cathode plate. It's a repeller plate. Fine. This is anode cavity. So the repeller so let's discuss the operation of reflex klystron. It can easily the operation of reflex crystal can easily understood by this Applegate diagram. We have to see Applegate diagram as well as the main diagram. Okay. The electron being injected from the cavity, its velocity modulated. Okay. The negative voltage applied to the repeller electrode, hence repeller electrode will repel the electron here. Okay. The repeller electron are retarded, so their energy is transferred to the cavity. Okay. Cavity is here, the gap. Okay. This will excite the cavity into self-oscillation, and the output power is removed from the cavity by the waveguide. So reflex crystal is a microwave oscillator, and it works on the principle of velocity modulation of electrons in a repeller space. The structure of reflex crystal, as we already discussed, it consists of a single microwave cavity with gap, cathode plate continuously which emits the electron, focusing electrodes which is used to focus the electron direction. Repeller, it repels the electron back to the gap of the microwave cavity. Repeller is connected to negative terminal of the repeller voltage, that is VR. Here. Reflex crystal consists of two batteries, high voltage DC batteries are there, namely anode battery, that is beam voltage, and it is connected to the anode cavity, and it is negative terminal, and its negative terminal is connected to the cathode plate. Okay. The battery, repeller voltage is negative voltage, and it is connected to the repeller plate. The magnitude of the beam voltage is greater than the magnitude of the repeller voltage. VA is greater than VR. The magnitude of VA is greater than the magnitude of the VR. So now the working of the reflex crystal, in which we consider three electrons, that is early electron, reference electrons ER, early electrons EE, and late electrons EL at the starting point of gap A. from the repeller side. So what is transient time? It's a time required for the electrons to travel from gap towards the repeller and then back to gap for microwave cell. The transient time for the electron is same and it is equal to the T is equal to n plus 3.4. The modulation of the speed of the electron takes place due to the variable battery repeller voltage. After transient time, that is T is equal to n plus 3.4, a bunch of early, that is reference ER or late electrons takes place and it is collected at the physical. Okay. Here you can see the early electrons, these early electrons, reference electrons, and late electrons. Okay, this is the Applegate diagram. So with the help of this Applegate diagram, I'm going to tell you the working box reflects this one. Okay. In this, it is assumed that the oscillations are set up in a tube. Okay. And as you can see in the Applegate diagram, the RF voltage is produced across the gap by the cavity oscillator and it acts on the electron beam, which cause the velocity modulation. So ER, that is reference electrons, are then passed through the gap beam with the gap voltage 0 and its ongoing negative. Okay, it's ongoing negative. Here. Reference electrons are unaffected by the gap beam, and this moves towards the repeller and gets reflected by the negative voltage on the repeller. Then it returns and passes through the gap for the second time. Okay. Then the early electron, that is EE. This passes through the gap before the reference electron and experience a maximum positive voltage across the gap. As you can see, get a maximum positive voltage. It moves with a greater velocity and penetrates deeper into the repeller. Okay. The return time of early electrons is greater as the depth of the penetration into the repeller space is more. Hence, early electrons appear and ER, that is reference electron. This. It appears at the gap for a second time at the same instant. Okay. The late electron that passes the gap later than reference electron experience a maximum negative voltage and moves with the retarding velocity. The return time is shorter as the penetration into repeller space is less and it catches up with ER and EE from a bunch and forming a bunch. Okay. Bunches occur once per cycle. And these bunches transfer maximum energy to the gap to get sustainable oscillations. Okay, got it? So the required condition to get sustainable oscillation in reflex cholesterol is this: P is equal to n plus 3 upon 4. For differentiate values of n, we get different modes in the reflex cholesterol, and modes in the reflex cholesterol is indicated by n. This. Great. For n is equal to 1, n should be 1 3 upon 4. That is fundamental mode. Okay. In second mode, n is 2 3 upon 4, and for third mode, n is equal to 3 3 upon 4. Now coming to the performance parameters of the reflex cholesterol. The frequency range of reflex crystal is 4 GHz to 200 GHz. Output power is 1 milliwatt to 2.5 watt, and its efficiency should be 22.78%. Practical efficiency between 10 to 20%, and tuning range is 5 GHz at 2 milliwatt and 30 GHz at 10 milliwatt. And the applications of reflex crystal are: these oscillators can be used in single source microwave generators, okay, and local oscillators in microwave receivers, and as a FM oscillator in a microwave link. That's it. Thank you.